This question came from an old exam, and on that exam it was worth 5 marks. And a number of students did very poorly on it as a result, and so we're going to look at what are some of the mistakes that were made on, what made this question difficult, because it starts off very similar to the questions that we have. We have a box in the shape of a rectangular prism. So here's the box with side lengths of x, x plus 2, and x plus 10. Write a function volume to express the volume of the box in terms of x. So my function of volume be length times width times height in no particular order. And that was worth 1 mark in this question. Then the other 4 marks came from the second part, which said find all possible values of x given that the volume of the box was 96. So we put a volume in at 96, and we have to find x. Now, what the exam was hoping students would do and what a lot of students actually did sort of contradicted each other and caused a lot of students to lose a lot of marks. It's non-calculator. At this point, what a lot of students did was saying, if it's non-calculator, x has to be a nice number. I'm going to try 1. If it's 1, I have 1 times 3 times 11. Does that make 96? No. So they tried 2. What's 2 times 4 times 12? Oh, it's 96. And they said x equals 2, and they were done. And they moved on to the next question. Now, unfortunately, the way this test was marked, that guideline said that if you use that guess and check method, you only got 2 out of 5 or 3 out of 5, a really low mark. What were they looking for? And how, as a result of this question, if this question reappeared, what would it look like to avoid the guess and check? So normally these questions says, find all possible values of x algebraically. They'll add the word algebraically, meaning you have to solve this. And now this one's hard to solve because we haven't done many where it's factored on one side with a number on the other. Hello?
David, please come to the office.
What was expected was that students multiply this out. So I'm going to multiply x plus 2 times x plus 10, so I'll get x squared plus 12x plus 20. And then I'm going to distribute the x, and I get x cubed plus 12x squared plus 20x. And now if I want to solve that equation, what I need to do is I need to factor it to solve, but first I need to make one side equal to 0. So if I move the 96 over, by subtracting 96 on both sides, I'll make one side equal to 0. And at this point, you needed to factor. Now, part of the problem with this on a factor theorem or remainder theorem kind of question, the factors of 96, there's a lot of them. There's like 1 and 96, 2 and 48, 3 and 24, and so on. No, it's not 3 and 24. But whatever. It would be 3 and something. That's not 24. 3 and 23. That's close. I was close with 24. No, it's not 23 either. Oh well. 3 and 32. But there's a lot of numbers. And if you tried to plug in 32, 32 cubed is a nice number to try and do without a calculator. But you already, with your guess and check, found out that 2 works. So if I let p of x equal this, p of 2 would be 8 plus 48 plus 20 minus 96, and sure enough, that equals 0. No, I made another mistake here. Man, you see it? Doesn't equal 0 if this is 20. But 20 times 2 doesn't happen to be 20. 20 times 2 is 40. And now it adds up to 96. Minus 96 is 0. So that tells us that x minus 2 is a factor. And if x minus 2 is a factor, we can now use synthetic division with the 2 out here, 1, 12, 20, negative 96. Bring the 1 down, 2, 14, 28, 48, 96, and yes, we get a remainder of 0. So we can say that our factor p of x is equal to x minus 2 and x squared plus 14x plus 48. Because although we figured out that x equals 2 was a possible answer, if we can factor this further, there might be more than one right answer. So factoring this further, since we have a quadratic, sure enough, this works to be x plus 8, x plus 6. And so our possible answers are x equals 2, x equals negative 8, and x equals negative 6. However, based on the context of the question, if x is one of our side lengths of a box, we have to say that these two do not make sense in the context. We can't have the side of the box be negative 8. So the only possibility is x is 2, and then our dimensions are 2 centimeters by 4 centimeters by 12 centimeters. Other small things, make sure you include units. If the question had units, like this one had centimeters to begin with, you need to have centimeters in the end. Make sure you read the whole question, because you might be so excited that you solved x equals 2 that you don't read that it asks you to state the dimensions of the box. So this question on reflection after the exam was probably seen as a little bit unfair because without a calculator, this was easy to figure out that it was 2. And the algebraic method without a calculator is only fair if it works with a small number. But anything bigger than 2, like even 3, well, 3 would still be okay, but maybe 4 would be very big numbers that you're dealing with already. So if you made a mental math error when putting in 2, and it didn't equal 0, like I did when I wrote 20 instead of 40, then you would try 3 and then 4, and then you'd be working on 48 and 96 and be doing calculations and not finish your exam. I will put one similar to this on your test next week, where you have to factor it completely, and it will say use algebra, not guess and check. So in these situations where you've got an equation and it's not equal to 0, even though it's factored, you have to expand it, move everything over, and then refactor it once it's equal to 0. So that's the part that's a little bit tricky.